Let's do this.
Okay, everyone. This is Quick. Good morning. Little cabal in the front, shut it down. Just shut it down. Ecker, shut it down. If everyone, yeah, but he's Joe Urecker, so. If everyone could have a seat, this is Quick. We have 2 hours today and 2 hours tomorrow, I believe. I think so, yeah. So let's go ahead and get started. First of all, this is the Note Well statement. You should be familiar with this, but if you're not, you can find it by searching for IETF Note Well on your favorite internet search engine, including Waze and Gopher and anything else, I guess. These are the terms which we participate in this work under, regarding intellectual property, regarding your behavior, regarding things like harassment, code of conduct. So if you're not familiar with these, please do take a look at them. We do take them seriously. And indeed, we have an ombudsman's team if you have any issues regarding people's conduct. So if you have any issues, please do talk to Lars or I or the other folks that are nominated for these roles. Spacebar is broken. There we go. Administrivia, blue sheets are going around. Thank you, Jonna. Where'd Jonna go? That's weird. Okay. We have scribes. Thank you very much, Patrick McManus, with a backup of Brian. Jabber relay. Craig volunteered to relay whatever happens on Jabber. Thank you so much. And we are using the Etherpad that's linked from the minutes, correct? Sorry, from the agenda, correct? Just if folks, we start having performance problems on that, people who aren't actively editing, disconnecting might be a good idea because Etherpad does tend to have some issues once you get a certain number of people on there. I'll let you two coordinate that in the case that it becomes necessary, if that's all right. Our agenda for today.
Reload.
A reload?
Yeah, I added the link.
I just did, but okay. Let's see. Oh, yeah, okay. So we had the hackathon on the weekend. Today we'll have a quick report of what happened at the hackathon from Lars. And then we have one discussion from the editors about discarding old keys. And then we'll go into the focus for today is mostly on the recovery draft. So Ian is going to go over what's happening with the recovery draft and the relevant issues. And we'll try and focus on that and take advantage of the time we have here in Prague with the larger IETF to talk about that, since when we have our interim meetings, it's often the case that we don't have all the right people in the room. If we have time permitting after that, we're going to have a quick discussion of quick connection migration. And then on Wednesday, we go into issue discussion on transport TLS and HTTP, talk about our next steps, and I don't think we have any other as time permits.
There's one pending that will be on Wednesday if it happens.
Okay. Any bashing on that plan of work? Okay. So before we get into that, a couple of quick things. I need to go back to this, don't I? So as you know, we have a changeover of the guard in ADs. So we wanted to take an opportunity to thank Spencer for being an AD for the life so far of the Quick Working Group. Thank you very much for your service. Stand up.
Yeah, thanks for chartering us.
Yes. And we'd like to welcome our new AD, Magnus. Magnus, please stand up and make sure everybody knows you. Sorry?
He's taking what?
Oh, dear. Don't go to the mic for bad jokes, please. So yeah, that's Magnus. If you have any problems with the way the working group's running and you can't resolve them with us, Magnus is the person to talk to. Make sure you forget what he looks like. No. Okay. That doesn't work, I guess. And one other thing we wanted to mention, we have scheduled an interim meeting for May the 20th, the week of May the 20th, I believe, in London.
You're welcome.
Yes.
The only person who knows it.
The hotel rates are surprisingly cheap.
We'll see how this goes. We consulted with a lot of people before we chose that date and time, and we waited as long as we could to see what the future would look like, and then the future changed very quickly, of course. So we're still going ahead at this time. I don't see us canceling the meeting unless things get quite dire, which some people predict, but people sometimes get in the habit of predicting dire things. So we plan to see everyone in London that week. We have an interrupt 2 days, and we have a 2-day working group meeting scheduled. With any luck, this might be our last interim meeting for the Quick V1 work. Well, no. You do that after. I can get a very reasonable rate on it. Trust me.
So on Wednesday we're going to talk about this, right?
Yeah.
So it depends. So whether or not we're going to keep having interims will depend on how quickly people will want to make progress on some of the stuff that is next on the agenda, like media over quick and multipath, right? So let's talk about that on Wednesday. And I see us also still organizing inter-ops, but since they're not IETF events, that is sort of a bit orthogonal to whether we're going to have an interim.
Yes. And indeed, one of the things we'll talk about is having physical interops separate from interims. But that's Wednesday. So today, let's get back into the agenda. Lars, how did the weekend go?
Went well. Can you click on the thing? The thing that says sheet somewhere. If you go up. Yes. That the Google Docs thing. Right. So we've been doing this for a long time now. Basically, these interrupts at the hackathon. And we have every time there's at least like one implementation that either hasn't participated in a long time or is new. So this was no exception. It's starting to look pretty solid in terms of the base functionality. There's a lot of green happening, and you see that there's pretty broad interop across the board. It's a little misleading. So some columns are dark, or some fields are darker than others. That's because we added a bunch of new tests for this interop round that not a lot of clients have implemented the tests for yet, like the NAT rebinding, or where the other guy speaks ECN and so on. So it's a little bit misleading, because I'm guessing that if more clients were testing these things, you would see darker shades of green, because some servers already support them, except that they're not tested for that yet. So it looks pretty good. I will point out that, so my personal opinion is that for specifically connection migration, there's a whole bunch of edge case testing that still needs to happen. At the moment, everybody seems to, so if somebody tests this, maybe with the exception of Christian, I don't know, but everybody just basically seems to close the port and start the port. So the IP address doesn't change, just port number changes. And there's not really any artificial reordering or any fancy stuff like that being introduced yet. So I expect we're going to hit some more corner cases there. But it looks pretty good. And given that, so this is dash 18 that we're testing here. 19 is already out with reasonably minor changes at the recovery and transport level. I think more of the changes are on the HTML side. It also looks pretty good. So this is compared to the last time I think we did this, there's a lot more H3 that's being tested, which is very, very, very nice. Mark always says it would be excellent if we actually got a browser very soon that did H3 over quick, because that seems to be a catalyst for many things. We're kind of hopeful that might happen soon. And if we get more than one browser, that would obviously be even better. But I think it looks pretty good. But the devil's in the details, and there's the basic functionality. When you have a nice clean path between the client and the server, things seem to work really well. I'm guessing that there's going to be a whole bunch more issues when we're running over some, stranger edge case paths. Sorry, say that again? So the IETF network is a pretty good test, because it's usually not great in terms of packet loss. And again, they had, so in Bangkok and here, there's a box in the network that likes to order UDP packets by size, which means that, so the NOC knows about this. We figured this out in Bangkok. The box is present. Somebody found it during the interrupt because they were wondering why they persistently got this one packet after the other. That is why. So the IETF network works an excellent test network. But we don't have sort of a lot of repeatability here yet, and then this comes back to tooling and automated test support. Christian.
Christian Uitema. Yes, one thing I did observe in this interop is that lots of stuff are working well, but if you start digging, like for example, if you start trying to download 100 megabytes or something like that, you do find issues, and there are lots of issues about confusion between the transport parameters one way and the other way, or this and that. So there are still, and then the retransmission and the management of flow control. I mean, we need more tests there.
I agree. So I think the first stacks are now sort of getting to the point we're doing, well, I think Nick has been doing performance testing for a while, but some of the other stacks are also now getting to the point where they actually wonder what kind of throughput they're getting, and where they actually try to push a lot of data over a connection or multiple connections, and that exposes a bunch of stuff.
Janayanga, just two notes. One, on that point, I think it's super important for people to start paying attention to the tooling stuff, and we are having presentations in TSV area on quick tooling, and that's going to be very helpful for working on performance going forward. I'm hoping that those folks will also show up to the interop to help people integrate their tooling with their own implementations. I don't know if we can do anything to support that, but it'd be lovely to actually figure out if there's a way to support, because at least one of them, Robin, is a university student, and lovely to get that support.
I mean, one thing is we have a bunch of students and academics show up that, I mean, if you're a professor, right, and you have students that are looking for master's thesis topics, this is not, I mean, there's PhDs here too, but a lot of the tooling is more like a master level kind of exercise. But it would actually help, you know, a large part of this community significantly if there was some more open source being written along those lines, right? And it makes for a pretty nice thesis. So come talk to the implementers. I think everybody has things like that are pretty baked, and somebody could go and do a master's on.
Yeah, I agree. The second point was Chromium. You talked about browser showing up. Browser did show up and actually did manage to work this time. So I don't see it on the chart though.
So I wasn't there for that. So maybe which browser?
Chromium.
Yeah, I'm guessing. So thank you for saying that. So yeah, there was I didn't know that line was actually Chromium rather than just a library.
Oh yeah,
I wasn't around for that. Okay, great.
Let Skenazi fill in the blanks there.
Very briefly.
David Skenazi, Google. Just wanted to clarify that is the Chromium implementation of QUIC, but we did not test the actual browser because as you can see, we have the Handshake but not HTTP, so the browser is not going to render anything useful. Yes, it is the Chromium code.
The browser is high, which is nice.
Very briefly, Eric Kinnear from Apple. We have loaded. There we go. Hello, that's better. Eric Kinnear from Apple. We have loaded QUIC over Safari, so all the way through the stack, top to bottom.
Awesome.
So, yeah.
Can we use that somehow? Can we get a build for that? Is that something that's possible at some point? Can I catch? No. Yeah. I'll take a new phone any day, but
I think that was a throwdown to the Chromium folks.
Oh.
But is the Chromium implementation actually called GQuick? That's super unfortunate. Oh, it's not GQuick. That's right. I'm sorry. That's what it is. It's not. It's still that GQuick. It's just sort of G. Fuck.
All right.
All right.
Anything else on the interop? Okay. Thank you, Lars.
Well, there was a discussion whether we're going to do a virtual interop day between now and London, and what version we would do it. So if you care about that, I think it's on the general channel on Slack. And if you're not on the Slack and you want to be on the Slack, send an email to Mark and me.
Yeah, for those not aware, we're using Slack as a way to coordinate between the implementers. It's not where any normative discussion of issues happens or anything covered by the IETF Note Well happens. It's just for coordination between implementers. Okay. So Martin Thompson, discarding old keys, please.
So this slide deck was updated, I think, yesterday. and it's out of date. So I'm going to go through it anyway. Part of the problem here is that we're dealing with, I think, 3 or 4 different things that we've, for various reasons, decided to lump into the same bucket. So let's go ahead and we'll see if we can make any progress here, but I don't hold high hopes. Next. Sorry, I should not be so negative this early in the morning. So talking about discussing initial keys as soon as possible, there's some debate about whether that's a goal. We're talking about discarding the handshake keys when appropriate. And there are some problems that we discovered in key updates that need to be fixed. Probably the biggest one being that if you update too quickly and both peers do that at the same time, you can end up in a situation where one peer cannot possibly, just basically forced to drop every packet on the ground. Basically kills connection. The agreement there was that we would limit the rate of key updates to 1 per RTT. And how we do that is up for debate, but that was the basic idea there. There was an express preference for explicit signals over implicit ones. Some people still think that timers are a good idea, but we'll get into that as I sort of work through the different options. Next, please. Do you have a clicker?
I can.
Oh, never mind. So the basic idea that we're talking about, and this was something that Nick came up with in the interim, was having an explicit signal that we could use to say it's okay to move to the next one, or probably maybe more precisely, it's okay to throw the other keys out because I've got these ones and we can proceed anyway. And so there's really 3 distinct cases that we're concerning ourselves with here, and each one has some different nuances to them, and so I think we'll probably go through that in a little bit more detail as we go. And I'm waiting for a clicker. Let's see how this works out. I notice that Mark's not willing to have the IETF clicker attached to his machine. Let's see if this works. Does this need to be turned on or something?
I did turn it on.
No, that's not working. Next. So we've had 4 proposals. I think there may be a 5th one now. I'll see if I can do that one justice as we work through this one. The first 3 of these use frames to sort of signal that things are ready to go. The 4th one steals one of those unused bits that we have in the first octet to create the signal. There's some fairly substantial differences between the first set and the last one in some regards, but essentially they're all some sort of explicit signal that we're ready to throw away the older keys. The difference is in when they're sent and how they're interpreted and what triggers you use to progress to the next ones. Can you press the next page, please? So the first one. This was my attempt to capture the state of the discussion out of the interim in Tokyo. And this is the first set of changes that you can see here on the slide over the past day. The idea was that you would send this frame when you believe that when you have read keys for something. But we realized in discussing this that what you really want to do is say, send this frame when you expect the peer to be sending with the corresponding keys. It implicitly identifies the keys. This is a point of difference with some of the other ones. If the frame is included in a packet that's protected with key X, then it means that I'm willing to receive the corresponding packets that are protected with the corresponding key. It doesn't have an explicit counter or something in there that identifies these things. And so if you start sending these packets after key updates, that means something different, which is something that we sort of do with acknowledgements, but maybe acknowledgements are so special that they're the only ones we can get away with that with. I don't know. When you receive one of these things, it used to say when you send it, but when you receive one of these things, you know that the older keys that are associated with keys from the previous epoch are safe to be discarded. You may want to retain those older keys, the ones you use for reading packets, for some amount of time. And there's some discussion in the document about how that works. But the basic principle is you're in a position now where you can throw those ones away, and you can proceed to make a new key update, which I think is the key fix for the key update problems that we're talking about. Next, please. I'm going to show some pictures. Hopefully these are decipherable at that range. It's very difficult to get these things on the one slide. But essentially what happens here is that when you send the first handshake packet, you say, well, I'm expecting to receive packets that are protected with handshake keys at this point. So I'm going to send this frame in that first handshake packet. And when you receive that packet containing this frame, it means that you're okay to proceed to the next one. And it also means that you're okay to throw away the previous keys. And so if you look at the third initial that's sent there from the client, which ostensibly contains an ACK of the server's initial, when that arrives at the server may have thrown out the initial keys depending on the ordering of things. Same happens at 1RTT. You'll notice that it's not sent in the first 1RTT packet because the server doesn't have the ability or doesn't have an expectation that the client is sending in 1RTT keys until it's gotten the 1RTT packets from the client. This is, I think, doing double duty here as I think the thing we've discussed many times is the handshake done frame. And we would use this as a trigger for other things. Eka.
Yeah, so just trying to make sure I understand at this point.
Yep.
So let's take that first transition. Let's assume like as seems natural that the initial and the first handshake from the server are bundled in the same datagram, and that the server and the client's implementing delayed ACK. So what will happen here is at the point where the client is ready to send initial, it'll already have received and processed the keys ready flag in the first in the handshake measure of the server, right?
That might be the case. I'm not sure that there's going to be delayed ACKs in this case because you're going to be sending packets and you'll stuff the ACKs in there.
Well, so the client is not. Let's say the client is not intending to send an ACK upon receiving the initial packet prior to receiving the rest of the stuff in the datagram, right?
Yeah.
You can call it delayed ACK or not as you please. So
it processes through the initial and the handshake, and will have processed this frame before it sends the color.
And the expectation is it will suppress transmission of that frame.
It could do so, yeah.
Could do so, or would do so, or must do so, and what's the interaction with the ACK? That is, imagine that for some reason that the ACK does not appear in the server's initial.
The ACK does not appear in the server's initial.
So now you have it standing on ACK data. The expectation is you would drop it.
So you would drop which?
So if the ACK does not appear in the server's initial, now you have a case where you've deleted the key, or you could delete the key per the rules,
right?
But you have it standing on ACK data. Well, that's the question I'm asking.
Right.
I'm attempting to establish what the proposed rules are. I'm not arguing. That's what the proposed rules are.
The proposed rules were that you can drop everything on initial packets, so you can throw that stuff away. And now you have a different channel for establishing that you don't need to resend that initial packet again.
So, but more generally, the rule is, and maybe I don't think this is the only case that can happen. Maybe it is. More generally, the rule is that that if you have outstanding data on an epoch that cannot or should not be sent on another epoch, when you receive keys ready on epoch n+1 or n+ anything, then you can consider that you effectively consider that an ACK, or you stop transmitting that epoch.
Yeah, you throw away all state for the previous keys. So it's not just the previous keys; it's all of the state associated with it, which means crypto frames and the works. Yes.
Thank you.
Yep. There's a bunch of discussion about that. You have to throw away recovery state and various other things as well. Next, please. So the key update is similar here. The difference being that you don't send the key ready frame when you send the first packet in the new epoch. You send the keys ready frame when you have an expectation that the peer is sending packets with the new epoch. And so for the peer that initiates the key update, they wait until they've seen packets from the new epoch before they send the frame. And the consequence here is that you're allowed to update once you've received the frame. And there's no way that you can use this state machine to do anything faster than one key update per round trip. And that achieves the goal. It fixes the problem where you can go from N to O without actually having packets from N in flight, and that causes the M's and the O's to be indistinguishable from each other and the connection to fail. So we patch the hole. Next, please. So David wrote up an alternative design for this one, and this one essentially says, rather than using the expectation of keys being ready, you look at the data that you have to send in a given epoch, and you say, has all of this stuff been sent to the other side and acknowledged? And so when you have no more to say, you then are able to do the key disposal and move on to the next epoch. This shares the property with the previous one that it implicitly identifies the keys. It does have a little wrinkle for the initial handshake transition. It's a special case. Like with the other one, you send it in the very first packet, and that triggers the drop of the initial keys in the same way. That's a little janky in some ways because it's not a consistent rule that you follow, but it has fairly similar properties. Next slide will give us a little bit more information about how that works. And so it looks very similar, but if you look again at the picture here, is this the one that you drew, David? Because I think this one's, I think you had the retire keys in the first RTT packet, the first one RTT packet from the client. Is that right? Is this right? Okay. It looks fairly similar to the other one. The difference is if you look at the one RTT keys, you send the retire keys frame later at the client. I'm not sure that I understand that though. Do you want to speak to this, David?
Yeah, I'm trying to make sure I understand too. So you send retire keys after all the data that in the epoch that you're retiring has been acknowledged?
Yeah, this is the question, please.
Yes, David Skenazy, Google. So we've been kind of going back and forth, and I think what Martin has been doing a good job demonstrating is we can't find a perfectly clean solution, but indeed in that particular design, that was the one I had a few weeks ago, the idea was that you send retire keys when everything that you want to send there has been acknowledged. From some implementers' opinions, it turns out in some cases it's hard to know when stuff has been acked because your act machinery and is kind of disconnected. So in that case, we could actually bring that message earlier. The system still works, but that was the initial design. Yeah. So earlier, this option.
So yeah, this one is driven by the receipt of the acknowledgement for the handshake packet. So once you're sure that you've received everything, once you're sure that the peer has received all of your handshake messages, you can then send the frame. Is that right?
Yes, it is. And just as an alternative, another way to key off, which we were talking about last night, is to key off the TLS state machine transition, where on the client, you don't react necessarily to a single packet, but when your separate TLS implementation off the top tells you, I am now connected, the handshake is done, and then you can send it then. That also works.
Let me just see if I can restate what you just said, which is that let's take the case of the server just for convenience, that the server would send retire keys upon receiving the client's finished. So in this diagram, will look identical, right?
No, it's the acknowledgement that's in the same packet.
Well, I know, but they're in the same packet. Well, no, he
Right.
just said, I mean, like, my point is that in this case, those two have identical timings.
Right.
And so I'm trying to understand, but he's proposing a different rule, which is it's on the state machine, right?
Yeah. So David's suggesting two different rules that are effectively the same, which is,
Not necessarily effectively the same, right?
well, no, not in practice, not in theory nor in practice, but in a lot of cases they will be.
Yes, I agree with that.
Yeah.
I wanted to, oh, sorry.
Oh.
Hey.
Yeah. The problem is this one's in the dark, and
Okay, I'll go over the next time. I just want to clarify another way I think of stating what, and maybe this is what David just said, is that once you are done sending at that encryption level, you send this frame, and once you have both sent and received this frame at an encryption level, then you know you are done and you can move on. And that's my mental model for how it works. And there's a variety of ways you can decide that you are done sending in that frame. It could be an acknowledgement, or it could be I have handshake keys, so I know the peer got my initial.
Well,
And that's an implementation dependent choice on each peer's side.
but I guess when you say, but just to be clear, what done sending means is, in this case at least, means I know the other side has received it.
yes.
That
In
is
some way,
like,
shape, or
like,
form.
like, so in particular, you couldn't send it. You in particular, you could not send retire keys, for the, in that first one RT packet, because you don't know, because you have to
Right.
retransmit the handshake, right?
Right. Right. You need to wait for some acknowledgement of some sort. Yes.
Great. Just as like, since people seem to be confused with this, I'm like not trying to argue with the merits of these things. I'm just trying to understand. I mean, I will in a minute, but I should make sure I really understand exactly what we're proposing.
Right. And that's the point of this exercise here that I'm going through, is to sort of plot out the design space for these things. Then we can talk about the principles that drive them, because that's important too. Next slide will actually highlight some of the interesting ways in which this changes. So what's interesting with this proposal is that you send this packet in the very first packet you send after a key update, because when you initiate a key update, you have to be sure that you are done with the previous epoch. So what this doesn't show is the next key update, but it does show that you can initiate a key update once the retire keys frame has been acknowledged, and the retires keys frame becomes the things that you would send in this epoch that need to get completed and transmitted and acknowledged before you move on to the next phase. So it's no longer crypto frames that we're concerned with here. It's the retire keys frames that you would use to drive that decision-making process. So I don't know how to restate that. Maybe John can restate that in another way.
Well, just a point of clarification, actually.
Yeah.
The retire keys are encrypted with the old keys, right?
No, they're encrypted with the new keys.
Oh, right. Because, okay, so the
Right.
assumption is that I know that the peer has everything it needs to use the new keys. Therefore, I'm sending the retire keys under the new key.
So the basic design of the key update is that it is always you can initiate it when you know that the other side is ready
Right.
for it to
that
happen,
makes sense. Yeah.
and we're putting the signal in at that point.
Yeah, thank you. Just wanted to get that clarified in my head.
More questions?
Yeah. So it seems to me that this actually is importantly different from the rule we applied in the previous slide, which is the rule we applied in the previous slide was the data has been delivered and acknowledged. The rule we delivered in this slide, however, is not the data has been delivered and acknowledged, because I can just send it. I can just send it again in the new epoch. And so like, I guess I'm struggling to actually wrap my head around exactly what the rule that I'm going to apply in my code is.
So this becomes the data that you have to send and have acknowledged for the next update.
No, I understand, but the point is that like so I'm sending an M, right?
Yep.
And I got like all sorts of data, like stream data standing in M, right?
Yep.
And that
But that stream data does not matter for the purposes of this calculation.
I understand, but the question is, when can you send retired keys, right? And you're going to say, but I mean, you're going to say that you can send retired keys when the previous retired keys has been acknowledged, right?
Yeah.
So, okay, you tell me the rule exactly like that.
So the rule of the retire keys proposal is you send it when you are done sending at the previous layer. So that is the rule.
That is not, that
So let me finish.
At the mic, please,
Yes.
Ecker.
So yes, I will expand. So the rule is you send it when you know you won't send anything else at this layer. So for, let's say that, for the handshake layer, what that means is everything you sent as handshake has been ACKed. For key update, there is a very key difference, which is, no pun intended, the fact that what you retransmit frames at layer M at layer N. So you know you're done sending at epoch M the moment you have keys for epoch N, because you know you will never send anything at epoch M anymore. You don't need an ACK at epoch M. You're just like, I have the keys, I will never send anything at epoch M anymore.
Yes, I understood this point, but the point I'm making is that that's like 3 different tests in the code I have to make for each different kinds of transition. Because the first rule you stated is not like actually mechanically enforceable, and the other ones are the ones mechanically enforceable, and so they apply different points.
Yeah, so that's absolutely fair. Yes, it is what makes it kind of clean is the concept. The implementation of this is not necessarily clean, and I agree with that. That's why we're all arguing about these things, because none of them are perfectly clean.
Clarification question. Sorry, you didn't sweat Google. If that matters anymore in this conversation. Does the ACK really need to drive this? Because we're not like actually looking for ACKs of retire keys. We're just saying you're done sending.
You don't send. Well, in this case, you need to use the acknowledgement to drive that. Otherwise, you don't get the round trip, and we're back in the soup again.
Why don't we just send a retire keys in one direction and then the other direction?
Because if you drive this just off the retire keys, you can get the simultaneous update, and then you end up with no round trip between that and the next one. You can actually end up in a situation where you go from M to N to O, and you skip the N, and you're back in the situation where you have packets coming in at one endpoint that are marked M and then O, and they have the same key phase bit on them, and they're indistinguishable.
Possibly there's a detail of key update I don't understand, but if 2 people simultaneously update, wouldn't they be in the same key phase at the same time?
They will be, but one of them doesn't necessarily know that the other one has initiated the update. And so if they both simultaneously update and send the frame at the same time, and from one side the packet is lost,
sure,
but that side will receive the frame from its peer and think it's able to make another update. And it can do that, let's say, half an RTT later, that it updates again. And so if all of the packets that it sends in that middle update are lost, it will have key phase 0, a bunch of lost packets on key phase 1, key phase 0 again, and what its peer sees is I tried to initiate a key update and the other side didn't do anything except it started sending me gibberish. And that's all we have at that point.
Okay. Thanks for clarifying. Yeah, I need to think about that more, but that's very helpful.
That's the essence of the bug that Martin found with the key update situation.
Martin Seemann, Protocol Labs. So looking at this diagram for key updates, it seems like all we are doing is looking for the ACK for the retire keys frame. So this would be equivalent to just not sending the retire keys frame and just looking for the ACK of a packet in packet phase N. In fact, the retire keys frame is strictly worse than this because it's a single signal as opposed to a continuous signal.
Correct. Yes, that is a nice observation. Thank you. Let's move on to some of the other ones. We've got some more interesting options coming up, if these ones weren't already interesting enough for people. So max key updates takes a different approach entirely. And it says, well, we have this thing that we do in the protocol where we say that there's a limit on how many things you can do of a given type. The number of streams, the number of bytes on a stream, the number of bytes in the connection, and we do the same thing for key updates. We say you can initiate 3 key updates, including the ones you've already done up to that point. And so you have a frame that has an explicit counter in it. So we deal with some of the retransmission logic problems that some of the other proposals had. You don't drive things off hacks. You don't have some weird retransmission logic for the frame. In case of a key update, you simply have the frame that you send. You can send them out of order if you wanted to. I don't know why you would, but same sort of logic that we have for Max stream data and all those sorts of other ones. And you use that to fix the key update issues. Use the first one of these to signal that you're willing to start doing key updates, and then you simply send them as you get key updates in a way that allows you to control when the key updates happen. And like most of these other ones, it means that you can hold off the key update until you're probably ready for it. What Kazuo proposes in this one is not doing anything for the initial to handshake transition and using the text that's currently in the draft that some people are unhappy about for driving that transition, and otherwise just using this frame to say when the key updates are possible. I think the very first one of them would be used as the basis for signaling that you're willing to do things like migration and all those sorts of other things. We should talk about migration as well, because that's something that's come up. Next slide, please. I think we have something here. And so the idea here is that you have the implicit drop of the initial keys somewhere. I'm not sure whether this is entirely correct, but you have the initial drop of the initial keys driven off implicit signals of some sort. And then once you're ready to start doing key updates, whenever that happens to be, you send this frame saying, I'm willing to do some key updates. I think 1 or 0 is the first one. I'm not sure whether that's, I don't think we fixed that one. I put 0 in, but I think we might want to say that 1 is the right answer there, but that's another problem.
Yeah, Jana, just again, point of clarification. What is that number supposed to mean?
So the number means the number of key updates that you're willing to accept, including the ones that have already happened. So if in this case, no key updates have happened, you send the frame, I'm not willing to accept any more key updates on this connection, is what 0 means. If you were to send 1, it means that you can update once. So if I were to send 3, that means that you can update 3 times. And
I see. So
that means from my perspective, I'm willing to do trial decryption to get those packets, because we don't have any explicit way of signaling which keys are being used on those packets.
So the moment in time where I would send that would be when I have both the read and the write keys available for this. And
this doesn't say anything about what the trigger is. It's entirely up to the endpoint as to when it sends this one.
Could that happen any sooner than when both the read and write keys are available?
Sure, if you're willing to do trial decryption, you can send this way earlier. But as a practical matter, you're going to do this when the handshake is done and you're ready to start reading with the new keys, and you're sure that you're fairly sure at least that you won't be receiving anything that can be confused for the key update that you're looking for.
So it seems to me that I think, and maybe this is the point you were trying to make by saying maybe there should be 1. It seems to me that it should be 1 because you want to allow for the next update to happen, right? Okay, yeah, and then we're on the same page.
Right. Yeah, so there's a mistake on the slides.
Christian Wittemer. When I look at these diagrams, there is one practical issue that I have, is that I know when I can stop sending any given epoch.
Right.
Because, I mean, if my packets have been acknowledged, I know I don't need that anymore. I could get rid of my write key, I could get rid of my cache copies, I could get rid of many things. What I don't know is when I should stop hacking whatever is sent by the peer. Because what I don't know, take the case of this diagram there. The client handshake contains the client finish, the first client handshake, okay?
Yep.
And the problem for the client, for the server, is to know when it has to stop hacking that thing. If the client repeats it because it believes it has not been hacked, etc. So that's really the rule. I mean, the rule, at what point do I not need to worry about sending repeated hacks and things like that?
If you would like to think of it that way, Christian, you're welcome. Thank you.
Victor Vasiliev, I have a question. So what are the circumstances under which I would want max key updates to have any value other than 0 or 1?
When you've already had key updates and you want to enable more. So the number continues to increase. It's not a 0 or 1. It's a continues
so
to
it's
increase.
like a flow control kind of
It's like a flow control kind of thing. That's the way you
okay.
need to think about this one. All right. I would like to accelerate this along.
Let's move on.
Yeah. Next, please. This one was in an earlier version of one of the pull requests that I put together. I think Kazuo suggested that we create a continuous signal by using one of those spare bits that we have in that first octet. Essentially, the bit would be you can initiate a key update from this, and it's carried in every packet. So it has the advantage of not having the problems that I think someone pointed out about, Martin pointed out about the frames that we have. If the packet containing the frame is lost, then you delay any updates by another round trip. This one, every packet contains the signal. It doesn't have any special retransmission rules. It's just a different way of signaling things. I think probably what we need to do now is discuss the principles that are driving this one, rather than talk about the specifics of the signaling, and talk about what the triggers are for generating that signaling. So I think I have a little bit more, but I can't remember what's ahead. Can we skip ahead to see what's there? All right, let's talk about this. They don't all use a frame. Again, slides problems. But there is an explicit signal in all of the proposals. What's interesting about all the proposals that hasn't been discussed so far is that endpoints can block key updates by not sending the frame. And this has some nice properties from some angles. And otherwise, what Kazuo pointed out is that with the ability to block a key update, you can also control the number of keys that you have active at any one point in time. So it's always the case that you can limit the number of write keys that you have to 1, because you only ever need to write with one particular set of keys, typically. During the handshake, it's a little bit funny, but generally you can limit that to 1. But the number of read keys that you have active, if you allow unbounded key updates, there's the possibility that you need to maintain multiple of them if you're concerned about not losing packets simply because they're indecipherable. The time limit there is something that was suggested, but primarily the time limit exists to deal with reordering on the network and delayed packets. But you can do things like delay the time that you send the signal so that you have a period of time to accept all the packets from the old keys before you allow even newer keys to be installed, and you can sort of cap things down. Next, please. What's different is where the signals happen. So Kazuo was arguing for an explicit counter. Any of these proposals can be modified to use an explicit counter, and then you don't need to worry about it. David's one less so because of the way that the logic works. The drawback is it's more stuff. It allows for more than one update. It can be wrong. If it's wrong, just ignore it. But there's a bit more logic involved in dealing with it. The problem with the encryption level and the ambient signal is that you need to worry about retransmission rules, whether it be to drive the logic forward or whether it be to suppress retransmissions of the frame. And it's smaller, but whatever. These things are infrequent, so I don't think we need to worry about that one all that much. Next. Kazuo suggests that the implicit signal on the initial handshake transition is okay. Others use an explicit signal. The thinking here has evolved a little bit. Those people who would prefer to drop initial keys as soon as possible, we should discuss this now, I think, if you want to talk about that, basically decided that you can throw away the initial read keys as soon as you have handshake keys if you want to use any of these mechanisms. And the reason we might want to do that is that we want to make sure that endpoints don't accept connection closes, for instance, in initial packets, and allow for denial of service for a connection that has gotten to the point where you have shared state of some sort with a peer. So let's talk about that for a little bit before we move on.
David Skenazy, Google. So absolutely, the initial keys are the ones that we really have a security problem if we don't drop them as soon as possible. For exactly that reason. They're not authenticated, they're not integrity protected, anyone can send anything there. So they're the ones where, even though I'm a very strong proponent of an explicit signal all the time over something implicit, you can't physically send a message at the handshake level that the client, like it'll receive it necessarily 1 RTT too late. So, that's on the server. So what that means is you have to key off of having the client and server hellos, which means that now you have the handshake keys. So as soon as you have the handshake keys, you need to toss away the initial. And Martin, do you want to talk about being able to discard the read and the write at separate times? I think that's a key property here.
Yeah, there's some interesting things to consider about the write keys in this context, but the risk of denial of service comes from having retaining the willingness to receive initial packets, which are not authenticated, as you say. And if those initial packets come from an attacker who's willing to inject a connection close, then you enter a situation where you are vulnerable to someone closing the connection after you've already reached the state where you have keys that you share with a peer. Now, you haven't authenticated the peer at this point, but you do have keys with someone.
You're wrong, David. Start that.
Who are you?
Eric Perscola. We're not really into that, are we?
That is your name, right? You're wrong.
Pretty much, yeah. I mean, so this is a set of trade-offs, and the set of trade-offs is a really quite minor denial of service exposure in a system which already has denial of service exposure at this point in the handshake, like 20 milliseconds earlier, against complexity in the protocol design. And so if it turns out that it's convenient to discard the keys earlier, then I'm more than happy to do it. If it turns out it's inconvenient, I'm not happy to complicate the protocol for extremely modest security benefit, if at all. And the complexity here is the complexity of having to manage the ACK state machine for this particular scenario you're talking about, where it's the server sending his first flight with the initial and the handshake, is a server having to separately manage the ACK state machine for the initial and the handshake in the case of the loss of the initial packet from the server to the client. In that the servers, ordinarily the server's initial will be retransmitted and we expect an ACK on epoch 0. If that is lost, if that is lost, then you're basically driving off some other signal, right?
There's more complication, by the way. I'll get
So
into that.
you're actually not. So the idea on the server is you drop the read keys for initial. You keep the write keys. So you put your server hello in your list of retransmittable outgoing frames, and your machinery will keep sending it until it gets ACKed.
It can't be ACKed.
Exactly. And then once you finish the entire handshake, you just toss the whole initial infrastructure away. So that's when you throw the read keys and the write keys, all the outstanding packets die. So that's not as clean. Yes, it doesn't get active. You just shoot that whole piece of memory in the head.
Yeah, and quite possibly you were transmitting like 5 or 6 times, even though actually you've got an acknowledgement for it, because the client certificate is potentially large and has to be transmitted multiple times. So, no, the server. What is it that causes the server to stop retransmitting its first flight? And the answer is that it receives some acknowledgement from the client. What is that message? Any handshake packet? Yeah, so this is like a wholly new piece of machinery to solve this like really incredibly trivial security problem. So it's exactly the thing I was complaining about.
Desa, you're right, but I would just say I don't think that it's a trivial security problem because like that is one of the things that we're trying to tighten versus TCP.
But the 20 milliseconds before you had it, the connection could be torn down.
But not the 500 milliseconds after. Yeah.
So I'm not going to cut the queues now, but I'm very conscious that, we asked the wider IETF community to come and talk about recovery in this session. And it seems like the number of people who are really engaged in this discussion is relatively small, and they see each other a fair amount. So let's continue, but let's keep in mind that maybe we have 10 or so more minutes to do this and see if we can make progress in that amount of time. Okay? Go ahead.
Martin Seemann, Protocol Labs.
You're off.
Mike. Hello?
Yep.
Eat the mic.
So in Tokyo, I like the idea of using a unified explicit signal for dropping the keys, all keys. But looking at the different proposals that were presented here, it seems like the initial and handshake keys are special. And we will need special rules for them anyway. No matter which of the three or four proposals we adopt, the rules for initials will be special. So we might as well accept that it's a special case and build a special case for this and use the explicit unified mechanism only for the key updates. So I now prefer having an implicit signal to drop initial keys, because I realized that there's a pretty cool thing we can do. Can you go back a slide to the diagram?
Oh, yeah, just pick any diagram. Yeah, that one.
So the server knows when it sent its server hello. So the server can drop the initial keys right after receiving the initial packet from the client. So the server will only accept a single packet with initial keys. So there's no injection attack possible in the direction of the server.
Yeah, I think this was the point that was raised before. There are complications with that, unfortunately. The primary complication there is the denial of service amplification mitigations that we have in place. And so whatever we do there you'd have to go back to the microphone. We'll have to deal with those.
For the mitigation of the amplification, we don't actually have to read the packet. For being
Correct.
unblocked by the 3x limit, we only need to receive a certain number of bytes from the same address. What's in those bytes doesn't matter at all.
I agree, yes.
I'd like to say that I very much agree with what Martin said. Okay, is that the initial is special, and you have to consider that any implementation will be tempted to do something special for the initial packets. So we could just as well acknowledge that and say, yeah, I mean, basically, if I have my handshake keys, I don't need the initial anymore. At least on the client side. I mean, on the server side, it's probably wise to keep it until you know that the client has a handshake key too, but it's...
Ian's right, Google. Yeah, I tend to agree that at this point we probably need to separate these signals. And that's mostly what I was going to say. And the other comment was that David and Martin's comments are interesting ideas. I think it's best to think of those as optimizations a server could perform rather than a necessary feature of this mechanism, because I think that, I don't know, if that's what, I think that's a better way of thinking about it personally. Yeah.
I don't understand what the threat model people are operating under is. In order to mount any injection attack, you have to have access to the client's initial. Because the client's initial is required to generate a packet to be valid for the server under this connection period. So the theory appears to be that the attacker, for some reason, has access to the client's initial, but can't get the packet in before the other packet happens, and also can't transmit its own bogus initial in the other direction, which will cause the client to shut the connection down. Like, neither of those things is true. In particular, the second one isn't true. And in particular, so look, so like, let us say that you have an attacker who's on path but can't control. And this goes back, by the way, to my request, which I'm going to actually write a threat model for this situation, as opposed to simply trying to find attacks that they can counter. That there are basically there are attackers which are on path and can see the traffic and will always win and can always put their packet in front. There are attackers which can never put their packet in front, and there are attackers which can sometimes put their packet in front. Those are the three categories of attackers. The first category of attacker will always be able to turn the connection regardless of anything we do here. The second category of attacker, you might say, would not be able to tear that connection because it will always lose race to the server. But they only want to win the race to the client. And so they only have to be in a posture which is slightly closer, which has to be, because they're in between the client and the server, they send to the client an initial, which causes the detection to be turned down. So someone please describe to me an attack which is actually defended against by this mechanism, that an actual task scenario is defended by this mechanism.
Yeah, I can do that. So the thing is, if a client receives an initial packet that closes the connection, a client might be willing to wait for a certain time if it receives another initial packet that looks valid, because the client has the interest in establishing the connection. So if you receive the attacker's initial, you just say like, okay, it looks like a connection close, but I'll wait for another 100 milliseconds or so.
It's not a connection close. It's
Yeah, you can send a valid server hello.
It's not a connection close. It's server hello with a wrong Diffie-Hellman key. Like all this stuff about how we're going to like build a branching tree of like all the possible states from the server. It's completely extra textual.
Jana and God, I think it's already starting to happen, and it might be worth actually not just continuing this conversation elsewhere. But what I was going to say is separating the conversation. What Martin Zeman said earlier is important in another way, which is that the conversation for when to drop the initial keys can be separate from what to do with the handshake keys and 1RTT keys. I think it might be useful to actually separate those two conversations, because then we can talk about the threat model for the initial separately and deal with that separately.
So I'm going to suggest that we shelve this particular initial transition discussion, because it's not going anywhere and we don't have a lot of time. But I would like to see if we can make some sort of progress on the key update one here, because I think we got pretty far. They are related if you consider that they're... If you consider them to be related, then you can use it. We decided that we would use the same mechanism for the two of them, but I think we've come to the realization that I don't think anyone's arguing for having the same mechanism for the two of them.
So hang on. So hang on. If we end up having the same mechanism for both of them, after we solve the two problems separately, we can use the same mechanism across the board. It's not necessary to start with that posture.
We're going to cut the line after Ecker, except if there's somebody that wants to speak on this that hasn't been in the line yet.
Right.
Yeah, I'm just saying that we don't need to start with that posture. We can solve the problem separately. If the mechanism ends up being the same, we can have the same mechanism across the board.
Kazuhoku, firstly, I just wanted to respond to Ecker's concern. And well, there's a merit of server discarding initial keys as early as possible, because that approach allows only the client. If the client has the capability of handling multiple pairs of keys, then it would work as a defense without requiring servers to do a costly work. So I think there's a benefit in letting the server to drop the initial packets, initial read keys as soon as possible.
Yeah, I mean, I think there may be some set of defenses, but like what I'm asking people is actually worked out. Like I've seen a lot of discussion in this working group over the past year and a half of like very specific attacks that we have very specific defense for without any concrete theory about what we're actually trying to accomplish. And what I'm asking for is a concrete theory we're trying to accomplish about what exactly the attackers are allowed to do and what the attackers are not allowed to do, so you can analyze the protocol against that. And the reason I'm pushing back, Martin, against saying let's just cut this case off is because if we solve these cases separately, and it's entirely possible there's a reasonable solution that's pretty good for both of them, and then we solve them together, and that's good. And if you say like let us build the absolute maximal solution for one and then not solve the other one, then it's possible to end up with a very bad solution for the other one because you haven't tried to solve them together. And that's why I'm pushing back on separating them.
So the reason that I suggested that is that these are very different things that we're discussing. One is a bug, and the other one is we're dealing with this threat model question that you raised, right? And I think we can fix the bug because we all agree that 1 per RTT explicit signal is the way we solve the bug. And so I would rather fix the bug, move on to that with that, and try to close that discussion, and then we can argue to our heart's content about the other one.
But it may or may not be the case that the best solution for the bug, that the solution for the bug that people propose works well for the other case. And so,
in which case, we can say, well, we'll just port the bug fix over to the other one. I want to make forward progress. That's all.
So do I. And so what I'm trying to do is avoid PSP solutions that don't make forward progress generally.
Okay, it seems like we're getting to diminishing returns in the discussion here, or indeed we've been there. Who in the room is in? Sorry, Ted. We'll get you in just a second. I just wanted to ask who in the room is interested and feels invested in the outcome of this discussion. Quick show of hands. Okay, it's mostly the usual suspects. Thank you, Ted. Please go ahead.
Ted Hardy, I'm not sure whether I'm a usual suspect or a diminishing return. Possibly
you can be both.
Yeah. So the point I got up to say here is actually to reinforce something that I think was said earlier, which is that if we do split this off so that these are 2 separate cases, then it's relatively easy to then look at what we're optimizing for in the 2 different cases, right? And what we may be optimizing for in the 2 different cases can be different. And in fact, I believe if we just took the retire keys proposal and said, look, retire keys works except in this corner case where you have simultaneous key update, unusual to begin with, and only one side of that simultaneous key update experiencing a packet loss of that key update, we can actually say, okay, that's a bug that causes a reset, and it's going to be rare enough that reassociation in QUIC is relatively cheap. Let's just do that. If what we're optimizing for is we never want to throw the packets on the floor, and therefore we don't want this case to exist, then we can go ahead with with a 1 RTT solution. But you're functionally, believe it or not, going to be reinventing the spin bit in the course of this by saying which one of them can actually update at any particular time. Because the way out of that simultaneous open problem is to only permit one of them to do it per RTT, and one side to do it per RTT. And guess what you just reinvented?
So I'm really happy that this group is so good at going back to the drawing board every time we discuss this issue. We discussed this in Tokyo and had largely the same discussion. And I thought that out of the discussions at Tokyo, we'd at least made progress on the key updates thing, but I'd like to see if we could get somewhere towards a conclusion on that. And even if we have to wind that back, I'd be happier making forward progress on that than...
Yeah, and just from my perspective, and Lars, please say if you feel differently, I'm willing to let the editors organize the discussion of how we make progress on getting this stuff incorporated in the documents.
No, it's just abdication of responsibility.
Yeah.
Right.
So
No. Oh. Go back there. We need to talk. I'm happy with the approach that Martin is proposing. I'm trying to support you, man. Jesus Christ. I'm less interested in having a discussion in the working group and coming to consensus about how we attack the minutia of each individual issue and how we stack it in the documents. I don't think that's a productive way to use our time.
This is not on the topic of, not on the technical details here at all, but we have had actually fairly good success with using small design teams in this working group, I think, in the past. Even on thorny, complicated issues, we've actually managed to make something. I know it's not the best necessarily way to go forward, but as Martin just said, we've gone over this several times, and every time there's just more things that show up, and we are going to keep going around in circles until somebody says, well, this is one thing, one way of doing it, and it's good enough, and we move forward. And it seems to me that if we can get a group of people together in a room, we can get this.
That was my next suggestion, was, the number of people who raised their hands looked a little bit too big for a successful design team. So if we can pare that down to something on the order of, I'm thinking 8-ish people, who are willing to spend some time this week, we might be able to make some progress.
I just wanted to know that that was the outcome of our discussion in talkies that we need to send him.
Yes, but we didn't have the chance to get them together for an extended period of time. Here we're trapped in Prague for a week.
And I will point out that at least the bug, right, we've actually hit in interop. So that is something that we certainly want to fix urgently. And the other issue we've actually also hit, where at least one stack did something that was legal according to what we wrote down, but it caused interrupt to sort of not work very great. So those are not sort of made up problems. They actually sort of we need to fix them soon if we want to ship V1. Brian.
Hi, Brian Trammell. One thing that I sort of noticed while I was trying to keep up with that discussion is that there does seem to be emerging consensus around splitting these, right? Like, so that seems like rough consensus, and I would say that might be the starting point for the design team is do the bug. I mean, it seems like that's where you were in Tokyo. I wasn't in Tokyo, but.
So if this team forms, I would personally prefer if somebody was coordinating this who wasn't an editor or otherwise already doing 10 different PRs. Right, so you don't have to step back if you
No step forward.
But somebody who understands this particular problem space and maybe has some spare cycles to corral the usuals together. David, thank you. Okay, cool. So if you're interested in this, talk to David.
And is it something that folks can make a little time this week to have an initial discussion at least? And indeed, if we could have a very short report tomorrow at the meeting, that'd be fantastic.
If anyone's interested, please come talk to me at the end of this session here, and we'll try to coordinate on some time because it's going to be hard to find a full
Can I
session.
put out there maybe lunch today might be an issue, might be an approach?
Think about it. Everyone's kind of making faces. Talk to me at the end of this, and then we'll figure it out.
Just show of hands, who's interested in being on this design team? David, have a good look around, please.
Yeah.
I see Victor Kazuho.
Everyone pick me on the quick Slack so I don't miss anyone's name.
Okay.
And if you don't have that, send me an email.
And create a channel there if you would.
I'll create a channel.
Okay, thank you.
Good thing we're not doing any working group work on it Slack.
Indeed.
Thanks, everyone. I'm going to sit down.
Thank you, Martin. Where are the blue sheets? Who has the blue sheets? One? Second one? Who has the other blue sheet? And who has not seen the blue sheet? Please raise your hand now. Okay.
Okay, well, this way.
We're still missing a blue sheet. I'm a little bit concerned, but
Make him go down the middle and then.
yeah. Okay. Next up, Ian Sweat. And if you could drive.
No, put it back.
People need that. Yeah. Can you drive this while?
Yes.
Should just be space bar.
All right. So first I'm going to start off with an update of recovery since Bangkok. So we've changed quite a number of things. Next slide. So a review of key points just about QUIC in general, just so if you're forgetting from Bangkok. Packet numbers monotonically increase in send order. ACK frames acknowledge one or more ranges of packets. There's an explicit ACK delay on each ACK frame, and the peer communicates the max ACK delay that it's going to use to calculate the timer value during the handshake. So each peer knows what the other peer's max ACK delay is. There was an overview at IETF104 from TCPM that Jana did. It's very nice, as well as 104 just yesterday. So the slides are linked from my slides. So there are almost as many changes since draft 16 as there have been in all previous revisions. I realized that when looking at the release notes. Yeah, there's been a fair number of changes. I'm going to try to go over all of them. Feel free to ask questions. And yeah, but we only have, I think, maybe now 5 design issues still open, which we will discuss right after this. Next slide. Okay. So one change that sort of simplified a lot of things is the old text and the old pseudocode assumed that you were either running in time threshold loss detection, so that's in some time space fraction of an RTT, or in packet threshold. So kind of a typical FAC or DUBAC style packet threshold loss detection. We are currently assuming now that you do both at the same time. This simplifies some of the mechanisms actually, because before, if you had only packet style, you still needed early retransmit, which is a separate timer-based mechanism, whereas now the standard time-based one kind of subsumes it. Yeah. Thanks. So a larger change is to merge TLP and RTO into something we're now calling probe timeout. QUIC's TLP and RTO were always subtly different from TCPs. And it was not really particularly well thought out that one of them had a very different formula than the other. So as you can see, TLP was 1.5 times SRTT plus max act delay, with also a min timeout. RTO was, SRTT plus RTT var. These two equations have something to do with each other, but are not particularly well related. TLP sent 1 packet, RTO sent 2 packets. RTO has exponential backoff, TLP did not. There was really no, I think, really good reasoning for the difference between the mechanisms besides kind of historical accident. So we combined them. So the timeout is now very similar to the old RTO formula. Smooth RTT plus max of 4 times RTT var and K granularity. This is actually taken from the TCP RTO RFC. So we're still very much in keeping with the TCP principles by using this value. And you send 1 or 2 retransmittable packets when this expires. So, oh yeah.
Eliciting, not retransmittable.
Yes. Touche. Thank you. Retransmittable has also been renamed to ACK eliciting. I believe that happened right before Bangkok, but yes. That is. They are intended to be the same thing. There is literally we replaced one word with another because retransmittable had ambiguous meaning. Is an editorial change. Ping is retransmittable and ACK eliciting. Yes. That. I don't have slides for that, but yeah, it was a purely editorial change. Just one maps to the other. Do you?
So Martin Thompson, just to clarify, retransmittable is a notion that doesn't have anything to do with whether you're going to actually retransmit something. It's perhaps a bad name, but it's the one we have right now. And
no, we have ACK eliciting now.
Yeah, ACK eliciting, right?
Yeah. Sorry, we had retransmittable, but it was wrong because you very well may not.
So Gary's going to ask you some questions about this one, rightly so.
Like, I got what it used to be called, and I still don't get what you are now wanting to call it.
It is now called ACK eliciting because what it means.
Eliciting.
ACK eliciting. Eliciting.
Yeah, I surely missed that. What on earth does that mean? But I'll read.
I can maybe John wants to.
Jana, let's try that with a few accents because this is a strange word. It's ACK eliciting, like something that actually gets the receiver to send an acknowledgement back.
Eric Kinnear, so do we actually need those to be the same thing? I know that right now it seems like everything is, but say we wanted to, in an extension, not retransmit a frame, but still have it elicit ACKs. Those are two very different concepts that are admittedly related, but very much not the same thing.
For the purpose of the recovery draft, the word retransmittable doesn't exist anymore.
I noticed that.
Yes, that's because it's not. It was just a misnomer.
Gotcha.
So that's the whole point. Is it confused people, understandably?
So we removed the word, which is not quite the same thing as saying that they must be equivalent.
We renamed the word to what I believe to be a more appropriate word, which is ACK eliciting.
Gotcha.
Yes, it is. The concept is exactly identical as it always was before.
So just to make sure I understand, the concept here is that you send a packet which would cause the other side to send you an ACK if it was going to send ACKs at all.
Within the max ACK delay, yes.
Yes.
That is the entire concept. Yep.
Thank you.
It's described much more nicely in the definition section of the draft. I did not put that in here because I did not realize that this issue was going to come up. Okay, great. So we did remove min RTO. This is in keeping with the max act delay or the MAD draft from TCP. And so MinRTO is now replaced by a combination of K granularity and the max act delay. So next slide. So Nick Banks very nicely wrote up an excellent PR that took a bit of work from a variety of people, but was really nicely done to redefine the concept of what persistent congestion is. So before there was this concept that when your RTO expired, you reduce your CWIN. So in TCP, when your RTO expires, you reduce your CWIN to 2. And that's kind of how you deal with persistent congestion. And then you unwind that if it turns out that the RTO is spurious. So in QUIC, we took the opposite approach because it was a little bit easier to implement and a little bit cleaner. That instead of doing an undo process, you actually wait until you get a signal. And then as soon as you get the signal, you decide, was that a spurious RTO or not? And so in terms of packets you send, it's largely identical. However, there are certain cases in this process due to where the timers are set that you can actually extend the RTO essentially. And you might not actually have an RTO or 2 RTOs or 3 RTOs fire. And instead, you might just trickle out some tiny amount of data over that period of time. And so the key concept here is CWIN is reduced to min CWIN when all packets prior to an acknowledged RTO packet are lost over a long enough period of time. Oh, next slide. Sorry. That's what I meant to be reading. I knew that didn't make any sense. And the period is currently 3 times the PTO timeout. So this is, in terms of time, very, very comparable to the old text. So we tried to keep it functionally as equivalent as possible. But this takes into account the fact that the application might be dribbling data for a long period of time, and the PTO timer might not actually fire.
Just clarification, that's not 3 times PTO, it's with the exponential backoff, right?
It's 3 times the PTO timeout is the current default. In the draft, it's written as 2 to the K persistent congestion threshold minus 1 times the PTO timeout.
Okay.
And K persistent congestion threshold defaults to 2. And so it ends up being 3 times the PTO timeout. Next slide. So we are now going to limit act delay to max act delay. So currently the concept of act delay is you have an RDT estimate that is actually observed, and then the peer communicates, okay, there was this much delayed act time before I actually sent that act, and so you can compensate in your SRTT measurements. However, one could potentially say, well, I know I have 100 millisecond RTT. I'm going to give you a 95 millisecond act delay, and that will cause you to shorten your timer, and especially with no min RTO, that could potentially cause a peer to spuriously retransmit a lot of data, either intentionally or otherwise. So next slide. So we now limit it to a minimum of act delay and max act delay, and that ensures that the peer is incentivized to actually advertise a max act delay value that is kind of consistent with what it actually believes it can achieve. And so if it advertises an overly low max act delay value, it'll just come out as into the SRTT measurement, just like it would in TCP. Next slide. Yes, we added some nice text on discarding recovery state. So this came up earlier with the various keys ready proposals. And basically there are a variety of situations in which you need to actually just discard your recovery state because there is no way that it could possibly be acknowledged. So 0 RTT rejection is one, dropping keys is another. And the solution is fairly straightforward. You discard all the recovery state for those packets in terms of tracking what's outstanding, and you remove them from bytes in flight because they can't be acknowledged or lost, and you will never know whether they are acknowledged or lost. So this is a fairly mechanical process, but particularly critical given the conversations about key dropping we're having. Next slide. Yes. So previously, the QUIC draft did recommend packet pacing, if at all possible. However, it didn't really say like what to do if you weren't packet pacing. And so now we're actually specifically saying that you should be doing slow start after idle if you are not pacing. And if you are pacing, then you can send up to an initial window, and then you must pace out the rest of the window. So we think this is in keeping both with kind of common best practices in operating systems like Linux, and also providing a suitable incentive to add pacing to stacks instead of sending very large bursts into the network. Praveen.
Praveen, Microsoft. So one comment here. So when I was reading the draft where this is defined, it's currently defined as the idle state of the sender is defined as when there's nothing to send, right? And there is nothing outstanding in the network. But if you look at the TCP RFC that define how to respond to idle, it basically says that there's a period defined for which it has to be idle before you reset the congestion window. So that period is defined to be worth a timeout, essentially. Okay. That ends up being like min-RTO and TCP, but I think we need a more crisp definition of what idle is after which you drop the congestion window. Okay. So that is missing. And the other thing I would like to point out is not many stacks are doing, TCP stacks are doing this by default.
Not many stacks are doing pacing, or not many stacks are doing slow start after idle?
Slow start after idle.
Okay. Yeah, I think quite a few Linux stacks are now doing pacing after idle, but yeah. Okay. Praveen, can you file an issue, editorial or otherwise, about the first point?
So
yes, I will.
Thank you.
Jana, can I just add a comment to that? Praveen, I think there's a difference though, right? Semantically. When TCP defines this, to be clear, there's no talk about pacing at all. So the expectation is that bursts are okay right after you've gone into idle. I think the premise that we've operated on, and maybe that's the issue that we need to discuss. The premise we've operated on here is that if you are pacing, then you should start pacing immediately as well. And the idea is that you shouldn't send a whole initial windows worth, or you shouldn't send a whole congestion windows worth of burst upfront. Now, this is different from what TCP does, and I would argue that TCP should also have this recommendation not to burst at any point in time. But that's a premise that we've applied here.
Absolutely agree. I think this is a good change. All I'm saying is that for implementations that are not pacing, the idle period needs to be defined more crisply.
You mean more liberally? Because it is defined right now. It's just defined as immediately.
I think that needs a little bit more debate, but yeah.
Yeah.
I'll open an issue and then we can discuss.
Thanks.
Hiren Panjasra. So I think rate limitation draft has some, rate estimation draft has some sort of a notion of idle connection, which is a little more elaborate than what we are aiming for here. So I was wondering if we can apply that in general.
Very, very possibly. I think to kind of go back to what John and Praveen were just talking about, I think it probably makes sense to figure out what our core goals are here. It seems like a good core goal is to ensure we don't drop large bursts into the network, because the network's likely to drop them. And so we need to balance that with trying to be a little more liberal with implementations that don't support pacing. So, but yeah, if you could add a reference to that draft to the issue that Praveen opened, that would be very helpful. Next slide. Oh, did you want to? Oh, next slide. Oh.
I would actually have expected Gory to be here because there is a TCP window validation right after, like, you spend some time in idle and you actually decrease your congestion window. Are you planning to somehow provide a reference to this, or to say more about how to decrease your congestion window in idle?
Oh, I think that is currently referenced in the text, but we don't actually, I think it's an informational reference, but there's no recommendation in regards to that.
Because if I understand it correctly, it's like either you do pacing and you keep your congestion window forever at a high level, right? Or you don't do pacing, you decrease it. So there should be some middle ground. You should reduce over time. That's what I'm saying.
Yeah. Do you think that's common best practice, or do you? This is an honest question.
Yeah.
I'm happy to have a.
Do you want to read
issue
up on this and make
that
an
as
issue
well.
for us?
Oh. Sorry.
You want to figure the details out and start an issue for us? Jana shakes his head.
Can I respond to it? Gauri. So, Jana Iyengar, we've done this, right, in TCPM for quite a while. It's called new CWV, and that's the draft that's actually referenced in the quick draft. We've gone through, the RFC now, and that's already referenced in the quick draft. And we basically said what Ian said is that we have stuff there saying you can follow the recommendations there, but we're just doing a bare minimum required here. I think the same considerations in that RFC apply here completely.
Yeah, but I think the bare minimum is resetting the window.
Gauri first, as part of the new CWV thing, but pacing was the big thing, and what you do afterwards, I guess we can just read the document again carefully and see if we can see anything. But pacing after being idle is the big thing that really makes a huge difference.
Sorry to close that off. I think we ended up having the discussion on the issue here in the room. Maria, you're right. That's exactly what the draft says right now, is you collapse your congestion window as soon as you go idle. And that's the conservative behavior. If you want something more liberal, then go look at new CWV is what it says.
Yeah, please take a closer read, and feel free to file an editorial issue if you think it's just insufficiently clear. So we moved the pseudocode to the appendix. The text was always intended to be normative and complete. I think there's still a few more PRs to make that actually true, but there's also ideally a goal that the pseudocode might compile by some definition of compile in the word Python, but it does not currently not. But yeah, the main goal here is to make the text a little more complete, and to make it clear that people should be primarily relying on the text and relying on the pseudocode just for clarifying questions.
Are you shooting for 2 or 3?
I think okay. I haven't programmed Python in 12 years. Next slide. Yes, the text and particularly the pseudocode for multiple packet number spaces has been greatly improved. This is all pretty much editorial work, but the draft 16 essentially said you should do loss recovery in multiple packet number spaces and kind of left it at that. The current draft 19 actually has the various pseudocode updated, so it kind of indicates what you should be tracking in multiple packet number spaces, and is generally clearer about how this should be done. So next, I think we're at the end. Okay, so these are just a bunch of, these are basically the release notes in 16, 17, and 18, so you can thumb through those, but this is the end of the slides. Do you want me to stay up here for issue discussion?
If there are any questions or other comments and people have their discussions they want to have about the recovery draft, now's the time.
Praveen, Microsoft. I noticed one more change that was not mentioned here, which was not grow the congestion window when your application limited. That's a deviation from TCP, and I think we need a lot more careful consideration before we put it in the draft.
Oh, interesting point. I think, is it possible that made it into draft 16 and that's why I didn't talk about it, or did I just miss it?
It's in draft 19 right now, so yeah.
Okay, I can go dig that up and yeah.
I can file an issue as well because I think that needs a little bit more discussion before we put it in.
Okay, sounds good.
Anything else?
So I have a question, right? So we have the new process that we're already applying to transport and to TLS. Sorry? No, I think this might lead to questions that I don't want to answer. But so recovery and HTTP at the moment do not follow the new process yet. Do people feel like specifically recovery is ready to be declared as capturing the consensus of the working group in -19, and then going forward we would apply this more rigorous process, or do we want to leave the editors with a bit more freedom to make rapid progress on the next version, I guess would be 20, and maybe then decide to rein it in?
And just to remind folks, the editors still have the ability to make purely editorial changes in terms of rearranging things and rewriting things that don't affect the normative heft of the document relatively freely under the new process. I think the question is whether that's going to be possible, whether the rewrites might impinge upon that and need some working group consensus at this point.
Praveen, go ahead.
Praveen, Microsoft. I think a little bit more
interop testing with like loss and latency might help. So we weed out all the issues. The other thing that might help is some sort of testing of TCP and QUIC on the same link.
Right. So I'm not saying that we want to close the document and freeze it, right? So we want to move to, for HTTP and for recovery, we're still giving the editors basically full control, letting them run ahead and change the text. And if people disagree, right, we're rolling back. This would flip it around where any change that Mark and I decide is not purely editorial would need to see working group consensus first. So this is what we're doing in this late stage process that Mark sent email about. And the question is whether we want to start applying the late stage process to recovery, and then there's going to be a similar discussion for HTTP.
That sounds reasonable to me.
Okay.
I'd like to hear what Ian thinks.
I think
Power.
I think we're getting close. I think it might make sense we have a variety of changes I hope to discuss today on the issues. I'd like to close those out and then maybe start the new process, starting with draft 20.
Okay.
That's my feel. I think we're pretty close to closing all the substantive non-editorial issues that are open. And so, yeah.
That sounds like between now and London, kind of?
Yes, that would be my preference.
Okay.
So maybe we can do 20 and then do it on list consensus call, kind of like you did. Yeah. Okay.
So over here.
Right, go ahead.
I think we're just now starting to see a lot of people actually doing interop with recovery and finding bugs. And I'm encouraged that most of the bugs that we found so far have been in the implementations and not as much in the spec. But at the same time, given the amount of stuff that we're trying to focus on, I don't think we've been steered wrong yet in recovery land by having the editors have a little bit more freedom to fix things up as necessary. So I don't have any objection to kind of raising the bar for that and switching to the new process. But at the same time, I'm not seeing as strong a need for it given the amount of time that we're trying to put into everything else.
Yeah. I agree with you, right? Transport is the one that's seen a lot of issues open against it continuously, and that we want to control. Recovery has been much more stable and it's much more steady development, right? And it's mostly sort of that eventually we want to basically have, we were kind of unusual when we started out because we wanted to move fast, where we gave the editors lots of leash. And now we want to maybe become more like a regular IETF working group where it's actually consensus-based. It won't change much here, I agree with you. It's just being clear about what model we're following.
Right. So, I
just wanted to interject one there. The other part of this is that as we move along, having the editor have that much capability also puts a lot of responsibility on their shoulders. And part of the discussion around TLS and invariance and transport was that was in some ways unfair to the editors. And so we're conscious that we don't want to put too much on Ian's shoulders here. The other factor for me is that in an ideal world, I don't want all the documents. I would like all the documents in one process rather than having a split process, because that's its own kind of overhead. Go ahead.
So, Jana Iyengar, as one of the editors of the draft, I can also say that I agree with what Kinnear is saying. What I'm seeing now is that there are people who are starting to interrupt and finding things. You just saw Praveen come and talk about something that's been there for a little while, but that's because they're starting to actually pay attention to the draft now. And I personally think that the load on recovery has not been very high in the past. It's not been very high, and I don't think and Ian and I think we might agree on this, but I don't think that there's been a tremendous amount of churn on this. And in the draft itself, I feel like there's some amount of agility at this moment would be useful. So I'm gonna push back against the late stage process yet.
Okay. So I think Ian's proposal was that we're doing it. We would maybe think about it for 20. And I also want to say that the late stage process really only makes a difference for design issues. And I don't see very many design issues for recovery. They're mostly editorial, where either things are unclear or there's a bug in the pseudocode or the text. But since we're not designing a new congestion control protocol here, right? We don't have very many of those.
I don't think that's true. I mean, literally the the two things that one of the things that Praveen brought up is a design issue, the application limited stuff, and we just fixed the persistent congestion thing last, which was a big design issue.
Let's not face plant on the exact mechanics of this. I think we could do this. We could talk about this again in London. So let's drain the queues and then let's move on.
Yeah, I was going to suggest that we target London-ish for the same process we did in Tokyo, which is surfacing the final issues, the last call for moving ahead. And then if editors feel like they need more time after that, then we can discuss in London. If they feel like they don't, then we'll be good.
I think that sounds reasonable.
Hi, Brian Trammell. I would caution a little bit against this because I don't think that the interop testing on recovery has pushed any of the implementations anywhere near the end of their envelopes, which is where weird recovery stuff is more likely to show up. I would say that we really need to have a few implementations stress tested to the point. So Praveen's run it on a challenging environment with TCP as well would be another thing that I would want to see before we say, hey, this is done enough that we can sort of go into the home stretch.
Martin, then Gory.
Martin Duke. Yeah, just to amplify that, I know about 4 to 6 weeks ago, Christian proposed on Slack that we add a interop letter for some sort of at volume testing, possibly in parallel TCP. And I think doing that in interop is probably the next best thing to actually someone deploying something like the latest draft in production, which it doesn't sound like it's close.
Gory Fairs back. I think the editors are doing a great job here. That they're really kind of trying to bite at the problem, but underneath they're trying to with a new set of mechanisms to make these things work. And I'm worried we haven't done the congestion collapse testing and really whether we got the words right. So I'd be really loath to freeze it. I think they should be given time to do it until the number of diffs reduces.
It's not about freezing the document.
Yeah, I know the process, but in some respects,
fair point. So we want to work as we have been working for a little while longer, and Ekro made a suggestion that maybe we revisit this in London. I think that's what we're
fine.
Yeah, I don't want to gate this on the amount of testing or the stress testing, but it does sound like that was a good suggestion. We'll talk about this again in London. If we think that it's appropriate, then we'll start the process in the list right after London.
And if somebody from the editor, from the implementers wants to write up a proposal for a stress test for throughput tests that we could all sort of implement, I think that would be useful, and pick a letter.
Yeah.
Anything else for Ian and or recovery?
No, we do. So Sherry, can you do tomorrow? Is that okay? Okay, great, thanks. So why don't we spend the rest of the time on issues and then we'll put you in.
I think we can get through all of, I hope, well, that's probably not true. I hope we can get through all of them.
Let's work on hope. Okay.
But I don't know if they're prioritized correctly. Do you want to just pull up the list of open design issues for recovery? I sent you a link on Slack that's mostly correct, except I did not exclude editorial.
One moment then.
Okay. I think I want to talk about them approximately in reverse chronological order. So most recent first, but I have to see the list.
Where did you send this link?
It was on the Slack editors channel. It was probably the last message that got sent.
Okay.
Cool.
Down here.
Okay.
Ian, look right there.
Oh, yeah. Sorry. I don't know why I was looking back at me. So let's do the initial RTT of 100 milliseconds first. That got comments most recently. So 2184. So the core of this issue is what should be the initial handshake timeout when you have absolutely no other information about the network for some reason. What are the defaults? So Praveen at the very bottom helpfully pointed me to a paper by a Googler from 2009 that kind of did a cumulative distribution of RTTs over the internet and said if you have a 1 second timeout, you will have a 2% spurious retransmit rate. According to the slides that, I linked to. And RFC 6298 recommends a 1 second timeout. My understanding is that is no longer the Linux default. I think the Linux default is 300 milliseconds. Can someone correct me if I'm wrong? And so there's sort of a divergence between common practice and what is recommended in the RFC. The number we currently recommend is a default RTT of 100 milliseconds, which results in a initial retransmission of 200 milliseconds. So, obvious numbers here that we might be able to pick are 200 milliseconds, 300 milliseconds because Linux does it, and 1 second because it's in the most recent RFC that references this text. To lay out some pros and cons here, picking a larger value by default is actually not all that bad because it might incentivize implementations to actually try to do something more intelligent, like remember recent RTT estimates or do other intelligent things that might be overall beneficial to the network. So I don't have a super strong resistance to it at this point. I think I resisted it more initially, saying that it seemed too conservative, but certainly implementations can choose to use other information, and that is explicitly called out in the draft. So I'm going to let Praveen go first because he opened it, but please don't.
Praveen, I kind of agree. So I think, but the recommended value in the RFC should probably be conservative with text there that implementations may choose to use previous information to, seed the RTT. I think it's only a problem when you're completely going blind into a network because you could be like on a satellite link and then cause spurious retransmissions for no reason. I think that's the reason we have a conservative value by default. But yeah, I think we should actually make a recommendation that implementations try to use the previous cache path RTT as much as possible. In that, if we do that, then I think the conservative value will not be that much of a problem.
And to clarify, is your suggestion that we use the 1 second value from RFC 6298?
That would be my recommendation. I think we should also run it by the Linux kernel implementers. So you do TCP to see why they changed it to 300 milliseconds. Maybe they have some data that we don't know about.
Yeah, if anyone here could add anything about that, that would be helpful. And Corey?
Go first on a slightly different tack. If we choose 1 second, then those people who get routed over satellite hops or very long devious routes because the operators decide to do that for their traffic, still function. If we have some caching method, then we can also deal with it, but please don't optimize just for 99% of people and then 1% get a big problem.
Yeah, I mean, we're mostly talking about one spurious retransmission of a single client hello. So it's
on those people on that path, it's every.
Yeah. Well, that incentivizes remembering information, hopefully. So to go with the point that I think we're converging on.
Michael?
Sure.
Yep. Emil?
I don't know who's first.
Sure. Yeah, I have one question with regard to the initial RTT. Does it apply to zero RTT connection or just to initial one RTT connection?
In practice, you would never expect it to apply to zero RTT connections because zero RTT connections should have the type of cached information associated with the zero RTT information. And I think we call that out in the draft. And if we don't, we should. I'm pretty sure we do. So we basically say if you, do zero RTT resumption, you should really store the RTT of the resumed connection. But the previous connection.
What we don't say is what you use for an RTO then.
We don't say what? Whicher?
If that's what you should retransmit at.
We say, yeah.
So just to level set here, how many issues do you think you need to get through here, Jan?
Like 3.
Okay.
This is the hardest one.
We're a little time constrained, so let's focus. Please go ahead.
Michael Tuxen, we have a working group document about RTO considerations in general and TCPM, and the statement there is you must not use a value less than 1 second. Capital letter must right now. The other thing you said, you cache the you use a cached value for the RTO from
for the initial RTT from the previous zero RTT connection,
which could be 1 year ago.
In practice, these credentials typically expire between 24 hours and 7 days.
Okay. Not a year.
So just one clarification, that is not just one spurious retransmission. Depending on the value we pick, even with exponential backoff, it could be 2 or 3.
Yes, although the number of users on networks with more than 2 second RTT is
More than 1 second, right? So if you pick 200, then it's like 200, 400,
Oh, sorry. I
800.
thought we were
So-
talking about the 1 second value. Okay.
Yeah. So if
Yes.
you pick lower than 1 second, then there could be more spurious retransmission for connections that do have RTT greater than 1 second.
I completely agree.
It's not number of users. It's for some users, this is all the time.
So it sounds like, so I heard mild preference to go towards 1 second, but point out that maybe Linux uses 300 millisecond and explain that if you can cache, you benefit.
So
I don't know if that's the way forward here.
Let's assume that's the proposal on the table.
I'm going to suggest something here, very specific. We actually have Michael Dixon pointed out RTO consider as a draft in TCPM, and we are going to have to, basically be zen between these two drafts for the IESG to stamp this anyways. So the draft actually, and I've discussed with Mark Allman the wording here, and it's very carefully written. It says, in the absence of any knowledge about the latency of the path, the RTO must be conservatively set to 1 second. To just counter what Michael said, this actually gives us room to do 300 milliseconds or whatever small value we want in zero RTT. And I honestly think that it's okay to be conservative in the non-zero RTT case, simply because it's not the common case anyways. And so it seems to me that we should be focusing on the zero RTT.
Okay. So I think we're agreeing with what you said. So
right. So we've got 10 minutes left. So let's drain these queues real quick and move on to the next issue.
Actually, can I ask, does anyone strongly disagree with the idea of just changing the default to 1 second and then maybe tightening up the text about zero RTT and making it clear that you really should try to use, some more appropriate value if you have better information? Okay.
I see agreements.
Okay.
Just before I answer that, I have a question. Are you going to use 1 second in Chrome?
Yeah, I mean, we don't today, but we will. Sure.
It's a serious question, because if none of the browsers use 1 second, then it's silly to say 1 second. If clients generically use like 200 milliseconds, then it's silly to say 1
I
second.
believe this will strongly incentivize us to keep a EWMA of recent Handshake RTT values and use that instead. That's the implementation.
Sure, I'm just making sure.
That's my implementation plan.
Sure. Okay.
I'm going to use 1 second when the browser starts up and I have no information, and never again. Yes.
Okay, Tommy.
Great, Tommy Pauly. So I like the direction of this. I think the 1 second with caching is a good approach. With regards to zero RTT, I think we still do need to make some recommendations about what you do in the absence of any RTT information, because you can definitely do zero RTT on a different network, right? So if I was on Wi-Fi, I've never been on the cellular network before, I don't know the RTT there, I do need to differentiate that. So when we're talking, if we're giving guidance about caching RTTs, I think we do need to be very specific that you can't assume the RTTs are the same across completely different network attachments.
That's a good clarification, although I would add that most of the time when you're doing zero RTT, you also need to have source address validation, and that would be different across SL and a Wi-Fi network. So you could do the resumption, the TLS resumption, but
right.
But you could do source address validation, so you'd be limited to sending like 3 packets or something.
Yeah, sure. But you still may, if you are doing zero RTT just for the TLS resumption, then you should take this into account.
Yes, that's a good point.
Craig.
Craig Taylor, relaying Ingemar Johansson. Note that LTE in some cases can have a ping RTT greater than 100 milliseconds because of various battery saving technology. On the other hand, a flood ping may give 40 millisecond RTT as the radio is kept alive. So that's just a practical example of, sub 1 second.
Emil?
Yeah, Emil, Orange. Can we just change the name from initial RTT to initial 1 RTT?
No, because
are
if you
you
don't have a cache, you would still use it.
Are you requesting a name to drop the initial request? Maybe I should clarify with you offline. Okay, thanks. Yeah.
Just one point, that in terms of cached values, I think it's cached per path. So it's a source dest IP combination. So when you change the networks, you'll be using a different source address, and that's is equivalent to starting the browser. So it's basically you're on a new network with no previous RTT information. So you should not use cache values.
Let's see if we can get through one more issue, maybe.
So while we're getting through, so I want to point out that during testing, we're doing interrupt, but it's actually very helpful to have two short initial RTTs because that means you have multiple handshake packets in flight, and that triggered a bunch of bugs. So for interrupt testing, we might want to keep using the too short value for a little while longer.
This is a question for the group. There's a parked issue, sender control delayed ACK ratio. This is helpfully opened by Bob Briscoe. There's extensive discussion, but at this point, I think we've all decided that this is probably appropriate for an extension or a quick V2. Is there anyone who objects to us closing this and declaring that I or someone else should write an extension for this? Oh,
Bob, do you still care?
I'm not saying it's not a good idea, and I very much want it, but in the interest of...
Hi, it's Bob Briscoe. I just want to explain the implications of not doing it.
Sure.
A number of networks or link technologies do ACK thinning, and the primary reason for putting this in, and they're all written, there are three main reasons in there, but the primary reason was that I wanted to make sure that QUIC did that ACK thinning for them to discourage them from trying to work out which were the ACKs and thinning them. Yeah.
It's a very good point. I think there are excellent technical arguments for doing
Bob,
this.
Are you okay with punting this to version 2?
Or an extension.
Or an
preferably.
extension?
I believe so, yes, because then we can see whether it happens.
I think some experimentation would be very valuable.
Okay.
Jana Iyengar, I think in the meanwhile, you want to definitely recommend, as I've had to a couple of people, that the smallest packets you see on the wire are not necessarily ACKs in QUIC. I just want to make that point because people have asked me that question for exactly that reason, because they want to thin those packets out. I'm like, no, actually, the smallest packets are not necessarily ACKs. They could be just packets carrying ping frames. So don't do that.
Can we close
Brian
this
says,
with
can you open an issue and manageability for that?
Yes, I'll do that.
So it sounds like we can close this as a quick V2, which
Yes.
is our kind of label for extension or next or whatever.
It's already parked, so one more issue I wanted to get to, which I think we can close now. But so there is should number of tail loss probes, aka PTOs now, be 1 or 2, 2185. So this is fairly simple. The text has been updated substantially. I guess my question to both Praveen and the rest of the group is, I believe the text currently says, I cannot remember if it says you should send 1 and you may send 2, or if you should send 2 or may send 1, but I think that we're pretty much kind of on one of those two recommendations. Do people have particularly strong opinions on this, or should we just stick with whatever is currently in the draft, which I apparently cannot recall?
It says should 1, may 2.
Okay. And then there's a consideration about why you might want to do 2, I believe, about delayed ACKs, or actually I think it's about packet loss.
So question, the persistent congestion definition sort of depends on the this currently, right? Because we previously said it's 3 times PTO. So if the implementation doing 1 time PTO, do we need to clarify that definition as well?
This is the number of packets. Oh, so this is not the number of
Yes,
packets.
this is the number of packets.
Oh, this is the persistent congestion. Yes, this is the persistent.
Oh, yeah, got it. Okay, no problem.
Sorry. Okay, yeah, so I guess this is persistent congestion. And
So the text currently is should for 1 and may for 2?
Yeah.
I think so.
No, hang on.
Are you okay with that, Praveen? Or would you like to see just should 1 like you?
No, that's actually perfectly fine.
Okay.
This is not persistent congestion. This is the PTO, right? Yeah.
Yeah. Okay. I think we can close this.
That sounds good. You got any more?
Yeah, we can do one more. Is there 2393. I opened this for Nick Banks, I believe. I don't think Nick's here, but there's a question of when K granularity, which is the alarm granularity, and the max ACK delay, which is the pure specified max ACK delay, should be added, whether it's before or after exponential backoff. This issue suggests it should be after. It is currently before. It seemed safer to add it before, and that's why I did it that way. I'm not sure if that's a well-reasoned argument.
Praveen, to me, it seemed like we have replaced min RTO with K granularity, which actually kind of makes sense to me because even in TCP, we never allowed you to set min RTO below the timer granularity. So it kind of makes sense that we cannot have a timer lower than that, right? And in TCP, the min RTO is included before. So in that spirit, I think keeping K granularity before is consistent with what TCP is doing.
Okay.
Like if you look at K granularity as a replacement for min RTO, then what we have right now is actually correct. But right at the end, I actually posted a comment yesterday where there was one possible change we could do to the equation. We could probably take that offline, but I think keeping K granularity before is probably more consistent with TCP.
Okay. Jana, you have 15 seconds.
Jana Iyengar, I'm going to agree with that. I'm going to give just add one more comment, which is the whole point of exponential backoff is that we waited this long and didn't hear anything back. So we should wait about twice as long. It's a rule of thumb. It's not, some sort of magical expression that's suddenly going to give us the right answer here. The point is to try backing off and backing off and backing off until you receive a response, and then you collapse the whole thing down anyways. So there's no long-term effect to this. I think just backing the whole thing off exponentially makes a ton more sense because that's the amount of time we waited.
Okay. Thank you. I will close this with no action then. Thanks.
Okay. Thank you, Ian. It's 11 o'clock. We'll see you all tomorrow, hopefully. Thanks.
I'm missing one blue sheet.
It's right up there with Bob.
Okay, good. So if you haven't signed yet, go to find Bob's corner.
So what's up?
Wow, this one is actually full. Yeah, maybe I'll take that. Thanks. Excuse me, just
this one's full. There's another one at the corner there.
Thank you. Hello, Peter. I need to